In this video, we are going to be talking about the graphs for the 6 trig functions and some of the characteristics that they have. We talked about in the last video a definition for radian and then also a definition for arc length. And I know that most of you have had a trigonometry class before. When we talk about the 6 trig functions for a particular point on a circle, that's related to the arc, or most of us think about it as being related to the angle, because when the radius is equal to 1, the arc length and the central angle have the same measurement. The key thing to remember is that the x-coordinate relates to the cosine, the y-coordinate relates to the sine, and then we have these other combinations, tangent, cotangent, which are in reciprocals of one another. Sine and cosecant are reciprocals of one another, and cosine and secant are reciprocals of one another. Pay particular attention to the fact that some of these functions are undefined in certain places, specifically when their denominator is equal to 0. This happens on the different axes, points on the axes, right, on the y-axis or the x-axis, and so that leads us to points of where the graph is not defined in some of the pictures and some of the graphs in the domains. This is just a repeat. There is a copy of the unit circle posted on Canvas for you to look at, but this is the picture that is up there, and you want to keep that handy with you to just kind of remember what the different sine and cosine values are for each of the key angles that we use on a regular basis. So when we graph the sine and the cosine button, they look like this. They're periodic functions. They repeat themselves the cycle is a distance of, I can see that the graph is increasing here and it starts to increase again here, and so the distance here between these 2 points is 2 pi. The way that I teach students to graph each of these is to think about the 5 key points. The 5 key points starting at the origin is at the midline, going up to a maximum, back to the midline, down to a minimum, and then back to the midline. So the pattern that sine follows is midline, max, midline, min, midline. This is the pattern that sine will always follow unless there's a reflection. And when there's a reflection, the max and the min points just interchange. But this is a way to remember how to get a graph. For cosine, we start at a maximum, go to the midline, minimum, midline, and back to a maximum. So max, mid, min, mid, and then max again. This is the pattern that we'll use whenever we're graphing either of these two types of functions. And this will be the case even when we have graph transformations, changes with the phase shift, changes with the period, changes with the amplitude. The domain and the range of sine and cosine are both all real numbers, the domain, and then the range goes between -1 and +1. Of course, that changes if we have any kind of changes in the amplitude. When we look at these 5 key points, as we call them, we have the beginning of the period is going to go from 0 and then to the end of the period. And then we split the period up in half, and then we split this in half again. And so this is where we get all of these key points to figure out where the x and the y coordinates are going to be. I mentioned that these are periodic functions, and the period for both sine and cosine is 2 pi. That's the distance in which the graph will start to repeat itself. Of course, we can change that if we add a number in here. If we multiply by a number in here, that will change the period. It will stretch or shrink. When we think about graph transformations, when we multiply a number inside the fraction, that's going to make a change in how things are horizontally. And so if we think about an accordion, multiplying by a whole number is going to shrink, and multiplying by a fraction is going to stretch. The amplitude is a number that would be multiplied on the outside potentially. The normal amplitude for sine and cosine is 1. It's taking that distance from the midline, in this case the x-axis, up to a maximum or down to a minimum. The amplitude is always going to be a positive number, so we think about it as the absolute value of a number that might be multiplied in front. For example, if I had, let's say, this, where I multiplied a number in front of the sign, it would take all those max values and stretch them from 1 up to 3, and all the min values would be stretched down from -1 to -3. Horizontal translations happen when we add a number on the outside of the function, so that will shift up for a positive number and down for a negative number. Sorry, I think I said horizontal and I meant vertical. Vertical translations shift up and down. For a horizontal translation, that's where we're going to shift left and right, and that's when a number is being multiplied or added or subtracted inside the parentheses. Remember that for our graph transformations, that a function is always going to move in the opposite direction because we subtract a number. If we're subtracting a number, it's going to move to the right. If we're adding a number, it's going to move to the left. So here are a couple example graphs. In this first example, what we have is a change in the phase shift, or a horizontal translation. The whole graph got shifted to the right by pi/3 units. Now, normally for this graph, we would have started at 0 and then gone down to 2 pi, with pi/2, and 3 pi/2. These would have been the regular values for the 5 key points. But what we do to get the new 5 key points is we're going to add pi/3 to all of these values. So you can see that if I started at 0 and I added pi/3, I end up here at pi/3. So that's my new starting point. My new starting point is pi/3. For the next value, we're looking at pi/2, and we add pi/3. Again, in your calculator, if you just add 1/2 plus 1/3, don't put the pi symbol in, it's going to give you 5/6. 5/6. And so that's how I know that this next point was at 5 pi/6. Again, I'm taking the normal breaks for where those max and min points would be, and I'm adding the phase shift in to get a new set of 5 key points. For the second graph, I have a phase shift. So the whole graph moves to the left by pi/4. And then we also have a change in the amplitude, right? So the amplitude is equal to 3. So I would be taking the 5 key points and subtracting pi/4 to get back to negative pi/4. Then the next one here's at pi/4, 3 pi/4, right? We've taken all of those 5 key points and shifted them to the left. I'm not talking about the values on the x-axis. And then for the y values, we stretch up to +3 and -3. The midline stays the same. The midline stays at exactly the same location. For this third graph, we have a reflection. We know that because there's a negative number in front, and a change in the amplitude. You can see that my max and min points end up going to +2 and -2, but the graph is flipped upside down. It might not look like it's flipped upside down at the moment because we have a couple things going on here. We have, let's rewrite this, -2 cosine 3x plus pi/3. So the period of this graph is 2 pi over 3. You take the regular period and you divide by this number here. So if I look at one of the maximum points, like here, and then to the next maximum point, that distance between those is 2 pi over 3. The whole graph also has a phase shift. It's going to be moved to the left by pi over 3. Remember that when you bring this 3 out into the front, you've got to factor it out of both items. So the beginning part of the graph actually is here. It went to the left. So rather than starting at 0, it started at pi over 3. And normally that would have been a maximum. Cosine has a maximum normally that it starts at, but it got flipped upside down. So just the phase shift would have started here. It would have been like this. But then the whole graph got shifted upside down, reflected, and that's why our starting point is down here. At first glance, it looks like this isn't reflected because there is what looks like a maximum point up here, but it's because it's a combination of a reflection and then also shifted over. In this graph here, our whole graph got shifted down by 1, so the midline is now at -1 rather than at the x-axis. The amplitude is 2, so I go up 2 units from that -1 to +1 for my maximum, and then down 2 units to -3 for the minimum. When you talk about the phase shift, you have to factor out that number b out of both items that are in the parentheses. So the phase shift here is pi over 4. The graph is moving to the left by pi over 4 units. So I can see that my starting point is here, right, to negative pi over 4. And then the period, we take this number, 2 pi over 4, the period is going to be pi over 2. So if I try to compare, let's say, 2 maximum points together, if I go from this maximum point to this maximum point, the distance there should be pi over 2. Let's see, it's negative pi over, well, that distance would be pi over 8 plus 3 pi over 8. This distance would be, this distance from here to here is pi over 8. And then just this distance from here to here is 3 pi over 8. And yeah, that's pi over 2, right? You're going to be using Desmos most of the time just to guide your thinking about the graphs, and you should have learned much of this in your trig classes. I am going to ask you for the key components, like what the 5 points are on the graph, the 5 key points, and then what each of the different transformational numbers mean. One fact that we want to keep with us is that the sine graph is an odd graph. If I plug in a negative angle, I get the same value back as the positive angle. So let's look at the graph of sine, or I get the opposite, sorry. Let's say that I go to pi over 2 versus negative pi over 2. The output values are going to be opposites of one another, right? +1 versus -1. For cosine, the graph is even. If I go to, let's say, pi over 4 versus negative pi over 4, I get the same output value. So sine is an odd function and cosine is an even function. Here are the graphs of tangent and cotangent. Again, they have asymptotes where we have points of discontinuity or where the function is not defined. Tangent is y over x. So whenever x is equal to 0, we're getting an asymptote. And we can see that those asymptotes are showing up at negative pi over 2, or negative 3 pi over 2, negative pi over 2, pi over 2, etc. Odd numbers multiplied by pi over 2. This is one way to write that. The function's defined everywhere except when we're at pi over 2 plus the distance between each asymptote is pi. Another way to write that is if I take pi over 2 and I add k times pi, or pi over 2 plus 2k pi over 2, just making the denominators the same. This is pi plus 2k pi over 2. Factor the pi out, and you get 2k plus 1 times pi over 2. This is a common way that we write this denotes an odd number, right? And so this is saying every odd number multiplied by pi over 2. For cotangent, cotangent is the reciprocal, so cotangent is x over y. So the asymptotes are going to show up wherever y is equal to 0. And so we get multiples of pi as the asymptotes, or the periods of discontinuity. The range for both the tangent and the cotangent functions is negative infinity to infinity. We can see that in the graphs. We do sometimes think about the 5 key points when we graph these as well, with a couple of things to remember. Tangent is an increasing graph, whereas cotangent is a decreasing graph. The 5 key points start at an asymptote, so the first one would be here at negative pi over 2, and then ending at an asymptote. One of the differences for tangent and cotangent is that the period of both of these graphs is pi, whereas for the other 4 trig functions, the period is 2 pi. So we begin and end on an asymptote, and notice that that tangent straddles the y-axis. Half of the graph is to the left and half of the graph is to the right. The quarter points are at pi over 4, which ends up being at negative 1, and negative pi over 4, negative 1, positive pi over 4, positive 1, and then 0, 0 in the middle, right? So this is negative pi over 4, and this is pi over 4. For cotangent, the first asymptote starts at the y-axis, and then goes, the next one's the length of the period, which is pi. So we have the asymptote, then we have the quarter point here up at positive 1, and then we have the quarter point here down at negative 1 with 0 in the middle, right? So again, the 5 key points include, for tangent and cotangent, they include those asymptotes on the ends. The last graphs that we're looking at are secant and cosecant, and they are reciprocals of sine and cosine. And so one of the ways that we talk about how to get these graphs is by graphing first. In this case, you can see that the sine graph is listed here. It's not part of the cosecant graph, but it's listed here so that we can see where the cosecant graph is sitting. The cosecant graph is just the parts that are pink, and the sort of relative minimum points fall right where there's a maximum for the sine graph, and then the relative maximum points are where there's a minimum for the sine graph. The asymptotes are not part of the graph, but we can see that they show up where the sine is equal to 0. Because when the sine is equal to 0, when we take that reciprocal, we get something that's undefined. We can't have 0 in the denominator. Similarly for cosine, the cosine graph here is just written as sort of a guide to show us where the secant graph falls. And wherever the cosine is equal to 0, that's where we end up with an asymptote for the secant graph. Similar to the tangent and the cotangent, we define their domains based on all real numbers, but then removing these sets of asymptotes and writing them in this form. And then the range is going to be everything below -1 and everything above -1. So that whole area in the middle of the graph is not included. All right, I know we went through this very quickly, but we'll talk about this in more detail in class. Have a great day.